Okay. I clicked on the link just to confirm. Okay. Good afternoon, everybody. Welcome back to this. Sorry, I'm trying to mute my audio so that I can be able to see those online. Like I was saying, welcome back to this particular training. Previously, we discussed on things like what a computer is, right? We highlighted some components of computing devices and so on and so forth, right? And then I left you guys in the hands of the able Abdul Muttalib, and I believe he did justice to Python. I believe he did that. Now, I am back to take you guys on a journey through something called database management system. Database management system. Now, we have some people online. I don't know if they can hear me. If they can? Okay. Okay, good, good. Now, sorry. Now, this course is going to be divided into two sections. The theory part of the class and the practical part of the what? Of the class. Now, I'm going to chew through the theory part of the class like wildfire today. Okay? I'll chew through it like wildfire today. From next week, we're going to go full practical. Full what? Practical. Now, the reason why I want to chew through the theory today is because I am of the opinion that a child that knows how to fish is better than the child that read about how to fish and is eating a fish, right? Because at any point in time, you can walk to the river and fish and catch a fish, right? But for the child that read how to fish and is eating a fish, will never know what it means to swim or to go to the river and catch one. So I believe in hands-on training, hands-on practical. That way, you can be a DBA administrator, database administrator, database analyst, database designer. There are so many fields under database management that you can fall into. Now, in the theory section, we'll discuss on the key concepts. Okay, we'll discuss on the key concepts. And on the practical part, we will need certain software packages to do what we need to do. Okay? Now, on the current slide, you will realize that we have something called video what? Video materials. Now, I will expect each and every one of you to install MySQL database and MySQL workbench on your computer. Now, there is a video for that. And I believe it will cost you not more than 20 MB to watch the video. Madam, you are opening your mouth. One of the pictures is 30 MB. One picture you snap and post to Instagram is 30 MB, and you're opening mouth for 20 that is going to benefit you for the rest of your life. So please open your mouth, okay? And then there is a tutorial series on MySQL, okay? And then there's a tutorial for what? Normalization. Now, in this particular class, we will discuss on normalization and what it is. Why do we even need to normalize data? Okay? All right. So, the theory section. Okay? This is the table of contents. In this particular class, we'll discuss on what is a database. We'll discuss on the types of databases. And then we'll talk about the database for this course. And then we'll talk about what? Data and data types. Okay? And then we'll talk about what? Entity relationship modeling. Okay? And then we'll talk about what? Keys and type of keys. And then we'll close it with what? Normalization. And under normalization, we're going to swallow the first normal form, second normal form, and what? Third normal form. Now, I was asking myself, how can I explain what is database to a child? A child in primary school, how do you explain what a database is? Now, this is what came to my mind. A database is like a container, or it's like a room where children keep their what? Toys. And each toy has a what? A specific section for it, such that whenever you want to pick out that toy, you know where to go. Even in darkness, the child will know exactly where to go to pick out that particular what? Item. I don't know if it makes sense. Does it? Does it make sense? Imagine you're telling this to primary school students. Do you think the person will understand? Then if that person will understand, then it means that most of you here understands what a database is. But then I'm not convinced. I said, okay, now let me go a bit higher. Since we're talking about primary school, let's explain that to a secondary school student. How do you go about explaining a database to a secondary school student? Now, the explanation I came up with is a database is like an organized collection of what? Information. It's a place where you can store all kind of stuff, like names, numbers, pictures, and many more. Now, I believe as a secondary school student, when you're in secondary school, you must have seen a cabinet, right? Unless if you went to free education as in primary school. But I believe as a secondary school student, you must have seen a cabinet. And in cabinet, you have what? You have folders. In those folders, you have what? Files. And on those files, you have what? The information, right? So now, what that would mean is, if I'm looking for certain information, I might decide to go to a certain folder, to a certain cabinet, open a certain drawer from that cabinet. Maybe we tag the cabinet A to B, C, D, E, F. So I drag in A, B, and then I'm looking for data that has to do with A, B. And then I have a segment that is only for A and another one for B. So I go specifically for what? For A. And then I pick out that particular part. I scout through that particular section to pick out the folder I'm looking for. Inside that folder, I have what? Files. So I have to go through those files to pick out the actual paper I'm looking for, right? So that is how I see it. That is how I see it when explaining this to a what? To a secondary school student. Now, one of you guys here are big boys and big girls now. You're past primary and secondary school, so I don't need to be giving you definition of primary and secondary school, right? So now, let's go to a more refined definition of what a database is. So now, a database is a structured collection of what? Data organized for what? Efficient retrieval, storage, and what? Management. It typically consists of one or more tables or files that are interrelated by what? Keys and what? Fields, allowing for complex what? Query. Now, you guys are going to learn those queries. And please, if you're working in the office, it's not the type of query they give in the office whereby they tell you they'll be given a query and then you start to shiver, right? Not that type of query. But what we are trying to say is the query is a way of communicating with database engine to pass information, to tell the database what you want it to do, and it will do it for you, okay? So that language is what you're going to learn in the practical part of this particular class, okay? Now, databases are widely used in computer systems to store and manage large volume of data for various what? Purposes, such as what? Business transactions, scientific what? Research, and what? Information management. Now, a simple example of database gone wrong is that particular period when MTN forgive everybody their loans. Yeah, when MTN forgive everybody their loans. You remember that time? That database gone wrong. Now, we've been talking about database. How is this practical in your real life? How is this practical in real life? Is the question, right? We'll come to that. Give me a moment. Let me check and see at what point are we coming to that. No problem. We'll come to that. Now, types of what? Databases. There are several types of databases. Each designed for what? Specific purpose and suits to different data management needs. Here are what? Some common types of what? Databases. You have the relational, okay? You have the NoSQL, you have the object-oriented databases, you have the graph databases, you have the document databases, you have column family store, and so on and so forth, okay? Now, in this particular class, this particular one we are holding right now, okay, so someone is asking online, Godia Luca, that this class is not for those in data analytics class, right? Yeah, it's not for data analytics, it's for software engineering. But if you're doing data analytics and you don't know database, it's like someone that is doing mathematics and doesn't know the plus and minus sign. So I believe if you are here, just stay here and be part of the lecture. It will be beneficial to you, especially for your own course, since it has to do with data. The venue is, what's the venue again? C21. C21 is the venue. So, the C21 Navi? So C21 is the value. So you come to block C and then room number 21, and you'll be golden. Okay. All right. So in this particular class, we're going to look at two types of databases: the NoSQL database and what? The relational. Okay. Now let's start with the NoSQL. NoSQL databases, or no, not only SQL databases, are a type of database, are types of database management systems that diverge from the traditional relational database model. Unlike relational database, which organize data into what? Tables and fixed columns. Sorry, can someone please get me water? I forgot to buy one when I was coming. Yes, I do, and please let me. No, I have to change it. I usually come with my water because my throat get dry easily. Just okay. So one of our students is out. Um, Welcome. Yeah, have a seat. Okay, so NoSQL database is not like MySQL that arranges data in what? Tables and what? Columns. Okay, that is why it's called NoSQL, NoSQL. Okay, now, now NoSQL database has a lot of applications in real world, uh, in our real world environment, a lot of applications. Like MongoDB, I use MongoDB when I'm developing apps that has to do with real time, okay? Apps that has to do with real time and so on. Now, the second type of database is the relational database. Now, these are the most common type of what? Common type and used, the most common type and use a structure that organize data into what? Tables with rows. Thank you. It organizes data into what? Tables and what? Rows and columns. Okay? And relationship between them. Now, some of you will wonder, how can tables and rows have relationships, right? We'll come to that. Example of relational databases include what? MySQL, PostgreSQL, Oracle, and what? MS Now, I've worked with MySQL and I've worked with MS SQL. Okay. Postgres, I have started working with it, but not in depth. But it's a very powerful tool to have in your arsenal. I'm not the football team. Okay. All right. This course will be based on this type of database management system, specifically what? Anyone? Specifically what? MySQL. Okay. Now, in real life, how many of you have been to a shop whereby you buy an item and then the person that sold the item to you bring out a book and write the item purchased? How many of you? Hmm? How many of you have been to a shop whereby you buy something and then the person bring out a book? Yes, hardcover book with columns and rows, right? And then they write serial number, name, quantity, amount, and total, right? And then each time you buy something, they write it down. Each time you buy something, they what? Write it down. That is the database. How many of you have been into contribution? Whereby when you collect money, you sign. Hmm? She's the one doing the central contribution, madam, for us. Oh, you're not the one? Why are you denying now, madam? Maybe denying. Okay, so how many of you have been to a situation, how many of you have been to an organization whereby before you enter, they ask you, who did you come to see? Which office are you going to? Is the person that doesn't know you're coming, and put your phone number, and put time, and take tag. And then when you bring it, you sign again. That is what? The database. At its primitive age. Now, imagine somebody comes and steal that book. Hmm? And then somebody stole, maybe you went to a mystery. Somebody stole the book and then they steal the minister's phone. And then they're trying to figure out who stole the phone. And the book is missing. How will they know who and who came in and who went out? Hmm? How many of you have been to a hospital whereby the moment you go there, they start telling you, you pay money for form, right? And then they give you what? Physical form. You write your name, your phone number, your date of birth, your house address, your husband's name, your uncle's name, who is coming to pick you, and where your village is, right? And then after you filled all that information, you pay money, they open what? A folder for you, right? And then they forward it to what? For you to go and see the consultant. You see the consultant, you open the folder, you write something in there, and then you tell you, okay, no problem, you can go. And then you forward the folder to somebody, and then that person tell you, okay, now you need to go and buy medicine A, medicine B, medicine C, and like, how many of you have been through that process? Okay, let's bring it closer to home. How many of you have filled the NIN registration? NIN. NIN. You filled it, right? They give you paper to fill? The physical one. They give you paper. Okay. And how many of you have applied for driver's license? Did they give you form to fill too? How many of you have filled voter's card? Did they give you form to fill too? Huh? Now, how many of you have been to the bank? And then, have you filled the form too? Yes. How many of you have been to secondary school? Have you filled the form too? Yes. So now the question is, why do we have forms all over the place? It's not we don't have the data, we have the data. How many of you are watching JAM? And JAM, they're a bit more IT-ish. But you hear that everywhere you go, you deal with what? Data. And most of the data you deal with is what? It's relational. What is relational? Let's assume we're in the IT savvy country. Once you go and register for your name, they'll give you your what? Your ID card. That ID card is your ATM card. That same ID card is your voter's card. That same ID card is your driver's license. Why? It's because data is what? Relational. You can apply data any way you want to. And most of the data that they are collecting is practically the same thing. So if you should give your name to VIO, they pull all your records from that name. You go to the hospital, the same ID card. You want to apply for primary school, that same ID card. Job, same ID card. Now, how sweet would that be? Let me not go there. So now, there are relationships between what? Between data. There is what? Relationship between data. Right now, we are here, we are where? We're in university, right? Now, let's take Base University, for instance. Base University has how many faculties? You guys are in the days, I really check. I'm telling them to leave you to go faculties in base. How many departments? What is the relationship between Base University and the colleges? It's a relationship called one to what? Many. We'll talk about those during the practical part of this particular class. That is the relational part of it. Base University has many faculties. Can many faculty have Base University? No. A child has what? One father. A child has what? One father. But a single father can have how many children? Many. That is what? One to what? Many. There are relationship that is one to one. The relationship that is what? One to one. One car has one engine. Have you ever seen a Peugeot station wagon or Peugeot 307 or any of these cars that you drive that has two engines? No. Because the relationship is what? One to one. And then you have many to many. I don't want to use boyfriend-girlfriend relationship in Nigeria, but I will have used that as the many to many part of the relationship. Even the girlfriends, many boyfriends. That is one to many. That is one to many. Okay. Someone online is helping us with the data. He says 5 faculties. I don't want to argue. Okay. Now, as stated in the previous slide, this course will be taught using what? Relational databases and MySQL database to be what? Specific. MySQL is an open source relational database management system, RDBMS. Now, what is open source? Open source. Something that is free. Right now, if Okatinubu make rice open source to Nigerians, now everybody will be smiling. Adi? We are hoping that things get better. Now, open source software is a software that you can use for free with no charges. Some open source softwares you can use as part of your own software and sell to make money. Okay? Madam. You are late. Eh? What's happening now, Okada? Yeah. Where's the traffic base? When I was coming, I saw so many police, road safety. Yeah, guys, always pray. Let VIO, make you and VIO no meet for road for problem. Always. MySQL database is widely used for managing structured data. It is one of the most popular database systems in the world and is commonly used for what? Web applications. Okay? Although you can use it for desktop applications, but mostly it works beautiful on the web. Okay? Now, there's something called programming stack. How many of you have heard of full stack? Now, there's something called programming stack, whereby you have something like LAMP, Linux, Apache, MySQL, and PHP. You have something like what is this stack? Oh, this it's oh um, React, ManStack. You have MongoDB, ExpressJS, React, and Node.js. Man, and then you have Merv stack. Somebody please send me charger. My charger is my battery is. Those of you online, sorry, my battery is running out, so I have to rush to go and bring my charger. If not, me I wanna no go see for road again. Sorry, Favor, Exam is actually an application that contains Linux, Apache, MySQL, PHP, Perl, and so on and so forth. Okay, so it's an app. Exam, you have things like WAM, it's an app too. It comes with MySQL and so on and so forth. Please, can somebody help me with the attendance list, attendance form or something? Okay. Okay. I'll behave myself and find charger quick. Okay. Now, MySQL organizes data into tables with rows and columns, similar to other relational databases. It supports SQL, which stands for what? Structured query what? Language for querying, manipulating data and communicating with the database, making it compatible with a wide range of applications and development frameworks. MySQL offers features such as transactions, replications, clustering, and high availability. Now, transaction can be said to be moving an item from one state of consistency to another state of what? Consistency. That is a transaction. Let me give you a simple example. Imagine you transfer money to somebody. Your database, your account is in a state of consistency. So at the point in time before you transfer the money, it's in a state of what? Consistency. When you transfer the money, it leaves that state of consistency to what? A new state. But then it takes to another what? To another pool, to another account. And that account changed from what? Current state of consistency to another state of consistency. Now, what happens when you are trying to transfer and it doesn't reach the other account and it doesn't come back to your account. That is when we say that the transaction what hangs, right? Meaning that it has changed instead of processing in this particular aspect, but that it has not reflected in the other side. And then it has not done something called roll back to its previous state. Because that is the essence of transaction. If it doesn't work, it should roll back automatically. Okay? All right. And then you have something called replica. Now, replica is the same thing as maybe you have twin sisters wearing the same clothes, with the same makeup, and then two different guys married the same twin sisters, and they wear the same clothes, and the two guys are trying to figure out which one is my wife. Hmm? That is replication. When you have two databases, one is waiting for changes to happen, but copies it to the other one to save. In the event this one falls, the main database is not working, the replica will pick up. Okay? That is what replication. Now, something called clustering. What is clustering? Clustering is a situation whereby you have multiple what? Replicas. You have many replicas, and at a point in time, you start doing things like load balancing so that when the request comes, it sends the request to any of the computers that is not working. Any of the servers that is not working, that request is sent to it to work and give out results. So you have a cluster of what? Machines. Okay? It's known for its performance, reliability, and ease of what? Use, making it a preferred choice for many developers and organizations across various industries. Okay? Additionally, MySQL has a vibrant community and extensive documentation, making it easy to get started and find support. Now, on many occasions, I will have trouble with my queries, and then I will search something maybe maybe I'm trying to do a subquery in a certain query. I have a main query and I have a subquery, and I'm having trouble. And then I'll just type subquery in MySQL, and you see a lot of options to go through. And believe me, within the first 3 search you do, you get what you're looking for. And you have a platform where you can go, it's core database related, where you can post questions and you get response from people around the world. In fact, people are waiting for you to post questions. You'll be surprised, the moment you post questions, before you click and open a new tab, open one tab to read something and come back, like 3 people have answered. That is how most of the platforms are, especially things like this server stack Overflow, and so on and so forth. I think it's SQL Stack or Server Stack. One of the two. I can't remember this thing. I know Stack Overflow. That one is confirmed. Stack Overflow. The moment you post, unless if you post users' questions and people give users answer. Okay. Now, database tables and fields. Think of a database as a container that contains many interrelated tables. For example, a university can have one database. In that database, there can be one or many tables, like table for students, table for staff, table for timetable, table for attendance, table for payment, table for admission, notification. There are many tables to go around. Now, a table can have many what? Fields. Fields like in student table, there is a field for what? First name, middle name, last name, gender, email address, cohort, year of admission, department, many fields. A field stores a specific data type in a table. Okay? A field stores specific data type in what? A table. Let me give you a simple example where things might go wrong. If you decide to store, let's assume they decide you can store anything in the table. You can store anything in a field. Whatever you want to store, you can store in the field. What happens when you want to enter students' total mark and you put D? Hmm? What will happen? Will it make sense? Let's assume the student scored CA 25 over 40 or 30 over 40. Exams, the student scored, let's say, 40 over 60, and you want to store the total in a field, and then you put D there. Would that fall under error? Well, now, how do you convert that into a grade? Because we have A, B, C, D, right? Is there F? Is there E and F, or they have moved E? Hmm? There is E? No, I know there is F. F down at Fatima Tara now. No, the universities, I think they have removed E. It stops at D. Yeah. It stops at D. D, I think it's up from 40, from 30, from 40 upward, right? From 40 to 45 is D. Then from 45 upward, I think is C. Is it from 40 to 50? Okay, 40 to 49. Okay. Okay. Now, a field that is designed to receive numbers will never receive a letter. It will throw an error. A field that is designed to store letter can receive a number. Now that's the beauty of MySQL. If you want to receive a letter, a number is a letter. So I'm asking in your exams or something that a field is designed to store characters, and I submitted 1. Will it accept it? Yes or no? And then you give me the answer. Okay? Now, there are types of data types. Okay, there are many types of data type in MySQL, and we discuss some of them here. In MySQL, understanding data type is very important. Okay? Okay, please, who else can see the attendance timer? Okay. I'm looking at those online, and they are saying the lecture is Kiniko. We'll continue like that now. Me, I'm a Nigerian. So let's continue. No. In MySQL, understanding data and data types is what? Very important. Since one of the core purpose of a database is to store what? Data. That is the core purpose of databases. To store what? Data. And MySQL can only store a single data type in a field within a table. Okay? It can only store a single data type in a field within a table. Now, you have to understand some data types are some data types can contain other data types, like have you guys discussed on string? Okay, you're doing Python, so you know discuss on string. No problem. We'll talk about it. Data types are important as designers, like developers of the database, need to know what type of data goes into what column of a table. Now, you have many type of data. but the core types are numeric, which includes what? Numbers. How many type of numbers do we have? Hmm? Which is what? Uh-huh. How many what type of numbers? Hmm? Type of numbers. Decimal and what? You are saying integer and float. You that know integer and float. We are trying to talk to people that doesn't know integer and float. We are trying to talk to people that doesn't know all these terminologies you are mentioning. Decimal numbers are not decimal numbers. Like, was this speaking the same English? Until I'm speaking English, you are speaking Igbo. This kind of life now. Chairman, you Kuma, we're going to UK. This guy is going to Ibadan. You don't even take road to follow us at all. I say you follow us. Now so you go, you go miss Salah meet for no reason. Okay? So numbers, we have two types of numbers, right? Numbers with decimal and what? Non-decimal numbers, right? Now, I believe those of you online knows that we have decimal and non-decimal numbers. Now, in MySQL, if you want to store numbers that have to do with decimal, you have two options. You can either use double or floats. Okay? Double or what? Floats. But for you that wants to store numbers that doesn't have decimal, you use what? Int. For what? Integer. If your number is very, very long, you can specify the length of number that you expect the person to enter. Most of the times, when people create integer values, they tend to give it a size of 11, meaning 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 figures. Now, I don't know of you, but I am not sure if a university can have 11 figures as their tuition, right? I don't know. Tuition fee, 11 digits. Eh? Eh, no. And put it on the paper and let's see if it's a billion or it's a million. Somebody tell us, 11 digits is what? 1 billion. So now, if you have 11 figures, that means you have to have 999999999 for you to be able to consume that space that you've allocated, which is not so impossible. It's not 12 billion. All the best. Now, you have something called char. What do you use char for? To store character. What is a character? Somebody will say, my friend, I used to be funny. It's a character. A character can be a character, like that chairman is a character. Thank you. Okay? Okay. Okay, let's talk forward, please. We have about 111 people online. And I will wish that they will be here for the practical part of the lecture because the practical part is the key. That is where you learn how to do it, not hear about how it is done. Right now, I'm teaching you how to chop the fish. There, I'll teach you how to catch it and put it on fire. I'll follow it to it. Don't worry, I'm not going to follow it to catch the fish, okay? All right, let's move forward. Now, you have things like character. You have things like Boolean. What is Boolean? True or false? True or what? False. You have things like date time, date time, and many more. Okay? Jason. There are so many of them. Okay? Chairman, Boolean is not true. Yes or no? Somebody is saying yes or no for Boolean. If you say yes or no in the exam, I'll just give you yes or no. In fact, I'll give you no. Okay? Now, we're talking about data, data, data. Mm. Special data type, I have never used it before. I can't give you a specific definition on what it is really. I've used virtually the rest. Mm? Special, I think that I have to check that. When you check that on online, I think you get a good results. Mm? I considered paper that somebody wrote item that he bought that somebody buy from him as database, and then you're asking for Excel. Excel is computerized database. I will tell you a story. When I went to school, my hostel was they were using Excel for managing the hostel. My hostel, let me see, we have three buildings. Each building has 12 floors. On each floor, there were 12 houses. So 12 times 3. Somebody help me with that. 432 houses. Now, in each house, there are 4 rooms. And in each house, you have uh, twin sharing, two twin sharing, and one and two separate. And they use Excel to manage our water consumption, our power usage, and they give you your bill. If you consume above what you paid, they will bring you extra bill. So it's a very, very huge, wonderful, beautiful database. Hmm? So yes, and some of the things you will do with Excel. Let's not go there. I've seen my dad do architectural design with Excel some time ago when I was growing up. Not architectural designs, civil engineering designs, structural, yeah, civil engineering designs with Excel. So believe you me, Excel is one of the craziest tool out there. You are looking at it as Excel, but it's more than that. Okay. So we're talking about data, data, data. What is data? Hmm? Information stored in database. This information can be what? Mm-hmm. 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 God bless you. Now, let's assume you have a table called student in the database. What fields should we expect in that table? Let's assume you have a table in your database called students. What fields should we expect? Mm-hmm. Mm-hmm. No, it's true. Mm-hmm. Account balance. Yeah, account balance. Is right. Course. There is a relationship between those two. Usually, we'll talk about the relationship. You don't have account balance. Okay. Is it free education? Okay. Data type in MySQL define the type of data that can be stored in each column of what? A table. They specify the format and size of the data, as well as any constraint or rules that applies to it. Choosing appropriate data type for each column is essential for efficient data storage and what? Retrieval. Okay? Data storage and what? Retrieval, as well as maintaining data integrity and consistency. Common data type in MySQL include numeric data type used for storing numbers, example, int for integer, decimal for fixed point decimal, and float for floating point numbers. You have things like string data type used to store used for storing text and character data. Example include varchar, char, and what? Text. Now, some of you will say, well, since because when you're typing text, whenever you are creating a database and you want to store text, and you use the data type text, then you should specify the volume of data you want to store. So some of you will say, but why don't we just use text for everything? It's not, we're talking about efficiency. Efficiency is the key. Why you use data type and you specify the volume. And data integrity. Let's assume a student ID consists of 11 characters. And then somebody is trying to store student ID that consists of 4 characters. Will it allow? What about somebody that is trying to store more than that? It's not supposed to allow. So if you put text, then everything can go in. Then you have date time, data types used for what? Storing date and time. Why would you need to store date and time? In case of, you said something? She's saying that we store data and time to know when data is stored, right? That's what you're saying, right? Beautiful. Now, let's assume that we don't have date time in databases. Let's assume. If you transfer money, let's assume you transfer 10,000, and it doesn't say the date and time that you transferred the money. And then you go to the bank and said, I transferred 10,000 yesterday, and it has not delivered. And they check their system. They don't have date and time. How can they track it? One of the first things they'll ask you is, when did you transfer the money, right? That's one of the first things they ask. Let me give you an example. Let's assume somebody added data, and that data becomes problematic for an institution, for instance. Let's assume among the items the person is supposed to pay, there is an item that the person is supposed to pay 100,000. Then somebody went and changed it to 2,000. Now, that will be problematic, right? Now, if you want to know who did it and when, now you don't have date and time, how will you go about it? So it's very, very important to always keep track of what? Date and what? Time. What about Boolean? How does it come into play? How does Boolean come into play? Not really. So let's take your example and elaborate on it. What she was saying is that let's assume you create an account. Let's assume you create an account on what? On Facebook, right? And then you try to log in immediately. They will tell you this account is not verified, right? Why? Because they have sent you a verification link to your email. Now, when you go and verify that, when you go and click that link, it takes you to a page, right? On that page, what it does is it changes your status from false to what? To true. That is it. You change your status from what? False to true. Let me give another example. Let's assume on the student portal where student is supposed to pay his school fees, right? There are items. Maybe you have the library fees, you have the give me the names now. I don't know all of them. No, you are going to pay your tuition in a university. Medical fees, caution fee, hostel fee, ICT fee, and so on and so forth, right? And then the university sat down and said, "Hi, this fees is too much. Let's do these students better and remove 3 items from those fees." Now, you don't delete data in the database. You don't delete. Because someone must have paid those particular fees previously. And if you delete the data, it will affect the other one. So you don't delete. So what do? You add status. And you put that status to be true or what? Or false. So when the university say, let's remove caution fee, hostel fee, let's do bonanza, let's do discount. So you just, anyone that is not active, you just make it false. So when the system is fetching to display to the student, it will only fetch the ones that are what? True. Does it make sense? So it has a lot of applications. These are just few. Believe you me? Not really. Not really, it doesn't. No, it doesn't. So in a login situation, what happens is, okay. Yeah, but it's not true or false. What happens is, when you submit your login username and password and you send it to the system, right? It takes that username and password and then it sends it to what? To the server. The server now takes the username and password and then it passes to the database. The database will check that username and password and then it will fetch the username. First of all, to check the record and see does that username exist? If it exists, then it compares the password. If it doesn't exist, it doesn't even need to compare the password. It just come and tell you wrong email, wrong username or password. It doesn't exist in the database. It's not that it's false. It doesn't exist.
When it exists, but your password is wrong.
It doesn't apply still. Let's assume it exists, but the password does not match.
What you entered at that time does not match what you entered.
No, it's not true or false. The true or false come into play when you are checking the logics that, okay, does the record exist? If it exists, does it match the database? If it does, that is when true or false apply. Okay? Maybe some other time I will open one of my applications and then I will show you how login works. It's crazy, it's funny. Okay, somebody is asking, Timothy Afolabi is asking that is string also referred to as character? It's a very beautiful question. Now, a string is a collection of what? Characters. A string is a what? Collection of what? Characters. Your name is what? I don't know. Before you specify me, I don't know. But my name is Hayat. Hayat is a collection of how many characters? 5. Meaning what? Hayat. They are separate characters. But when combined together, they form what? A string of characters. Now, the question is space a character? Not because Python count it. It's a character. How about minus? It's a character. How about underscore? It's a character. I don't know if I'm making sense. Okay? All right. Then you have the binary data type, which include things like blob for storing images and var binary for storing images too, practically. Most of the large data types is for storing. These are for storing large data into a database. Okay. Now, database data types continue. Now, numerics, you see them, plenty. Data time, you see them, plenty too. String, you see them. Spatial, geometry, line, polygon, and so on. That's the question you're asking, right? And then you have JSON. Okay? Now, I brought this photo from Phoenix Snap Global IT Service because I have to say it since this thing comes out. Otherwise, I'll keep quiet. What is true or false? The photo? I copied from the website, actually. I don't understand. Oh, you asked me if this data is correct. Chairman, now look at it now. Now, let me give you a simple example. Numeric. You have ints, which is integer. Floats, which is what? Decimal. Double. Decimal. Decimal itself is a data type. And then bits. Bits does what? Bits. What is it? Bits? Zeros and one. Okay? So bits can go for Boolean, if you may. Date and time. You have date time, you have date time stamp, you have date, time, and year. They're all MySQL. They're all MySQL reserved keywords. Okay. You have string. String contains char, binary, char, binary, blob, text. They're all part of string. And then you have geometry and JSON. JSON is a Java object notation or something. We used to store data using key value pair. Okay. Chairman, how many hours do we have left? 20? If I no talk within this musician talk, we never even reach half yet. Okay. Entity relationship. Entity relationship or entity relationship model. Simply ERD for the diagram. Entity relationship model is a technique used in database design to visually represent the relationship between what? Entities, objects, or concepts within a system. It helps developers and database designers to understand how different pieces of data are related to what? To each other, and how they interact. Because believe you me, when we start the practical aspect of the class, you will realize how data interacts with each other. In an entity relationship modeling, it is paramount to know the following. One, entities. Entities represent the real world objects or concepts about which data is stored in the database. More like the tables in the database. Okay? More like what? The tables. Then you have attributes. Attributes are the properties or characteristics of an entity. They describe the various they describe they describe the various pieces of information that we want to store about each entity. Let me give you a simple example. An entity, let's take a car to be our entity. What are the attributes of a car? Color, size, model, time, type, year. Now, the question I'm going to ask you is, can you at a single sitting enumerate all the attributes of a car? Yeah. All the attributes. We said that the attribute is a car. The entity is a car, right? Now, the attributes. Can you, in a single sitting, enumerate all the attributes of a car? Even the maker of the car, you cannot. Even a group of people is going to be difficult because attributes include every other thing that is within the car. It's an attribute. Sub items of that car. Go into the engine and you realize what we're talking about. Now, relationships. Relationships describe how entities are connected or associated with each other. They indicate how data in one entity is related to another data in another what? Entity. Cardinality. Cardinality describes the number of instances of one entity that are associated with another entity. Common cardinality notations include one-to-one, one-to-many, and what? Many-to-many. Attribute and relationship. Relationship can have attributes which are properties or characteristics specific to the relationship itself. Now, if you look at this table here, if you look at this table here, is an entity relationship diagram of what? What is relationship? From looking at it, what does this diagram tells you? What is it for? Is the database of company for what? It's an entity relationship diagram for an employee. It's an entity relationship diagram for what? An employee. So each item, each table you see here is what? It's an entity. And then you have the properties, which is the employee ID, first name, middle name, last name, which are what which we called what in the previous slide? Attributes, right? And then you have data type by the side. Is it integer, virtual, and so on and so forth. Now, what is the relationship between these tables? So what is the relationship? Anybody? Yeah, but how do you read it is the question.
Like there's many jobs to one employee and also the dependency. So the thing is many one to many.
Hmm?
One to
One employee has many dependents. Hmm? One job has many what? Employees. But then this can be a many to many relationship. It can be a many to many relationships. Many people can be working on one job. And one job can have many people working on it. Oh? So it can be many to many. Then you have departments. An employee, one department has many employees. Then many departments are in one location. Then many locations are in one country, and one country is many countries are in one region. So if you notice, you see that there is a relationship, there is linkages. Now, this one that is above that who that is anyone that gets it is I have 2,000 naira right now.
okay, this one
Eh?
is just like
I have Hey, my water don't fall. I have 2,000 naira. Hmm?
at the same time, many are asking
This one at the top here, this side here, at the top. What does it mean? Mm-mm. What is the relationship?
like having okay, I think this is so this means that many employees are used one of it like this entity. It means that one employee has
Hmm? Should I tell you the answer? 2,000. Hmm? Hmm? Come again? CEO. No.
maybe last time. So this is just a user for the
Mm-mm. One manager to many employees. This is manager. This is that one manager here can have many employees under him. So the same number of that manager will fall on all the employees that he's managing. Okay, my 2,000 is safe. You know, you know, you know, when I was in Casina, I used to do this a lot. I give a class work and then I mark it over 40 of your CV. If you can do it, I believe you can pass the course. And then when I was working in days, I used to buy chocolates, one whole pack. And anybody that comes late or you answer my question, I'll give you two. So don't worry, we'll catch fun. We'll catch fun. Don't worry. Somebody will eat my money very soon. Don't worry. Eh? Nobody answered online. Nobody answered online. Mhm. One, many. So one department has many employees. Okay? So like one manager has many employees under him. That is the manager indicator. If you notice, the coloration is different too. Now, this one that has a key, yellow key, is called primary key. I'll come to that when we start doing the core work. And then this one that has diamond, diamond, it's called a foreign key. And it's foreign. And Nigerians like foreign things now. You know that one. Foreign key, meaning that it's a primary key in another table. So since the primary key in another table, in this particular thing is a foreign key. Now instead of us directing the department name of all the staff, we just put the ID. So we just connect these two, get the name of the staff and the department it belongs to. We'll do that in the database particular aspect of the class. Really, guys. Really, guys, you have to be in the practical part of this class because we are going to discuss on so many things that are very relevant to this particular course. And believe you me, I am optimistic to be fun. Believe you me, I'm optimistic. Now, please, for the sake of God, try and install MySQL Workbench on your computer. Please. It's on the slide. I will send the slide after the class. Okay, so let's keep moving. Keys and type of keys. Now, the primary key is a unique identifier that identifies a row in a table. Okay? The primary key is a what? Unique identifier that identifies a row in the table. Now, the primary key is a unique identifier for each record in the table. You see the same thing as I said. It ensures that each row in the table is uniquely identifiable. Primary keys must contain unique values and cannot have null values. Now, in some situations, you might have values that are what? Null. Okay? In some situations, you might have values that are what? Null. And one of those situations is, let's assume you have an application where someone is supposed to register and then log in and then make payment. Now, when the person makes payment, you want to update a certain column to the transaction number, the transaction code. When you create the record at the beginning, the value will be null. Okay? Let's assume these are students, right? These are students and their courses, right? Now, we want to add another column that is called payments. As at the point of adding the students, they are not expected to pay. So that column that you're supposed to add the payment will be null. When the student makes payments, then you store the transaction ID of that particular transaction in that particular column, in that particular field. Okay? All right. Does that make sense? Okay. All right. Sorry, guys. I'm trying to explain something on the board. That is why it's of high importance for you. If possible, please come to the university. Most of the guys here are having a blast. I'm not talking for myself, I'm talking for them, so don't mind me. They're not having a blast. They are just saying, finish, let's go and eat. I'm a student now, I know. We're all there. I've been there before. That is the frustrating part of it. Wallahi. That is the frustrating part of it. Someone is still trying to chop my 2,000 naira online. That ship has sailed. Wallahi, that ship has sailed long ago. It's all about it. Okay. Now, foreign key. A foreign key is the primary key of another table in another table. Hey, wahala don't come. Let's go back. A foreign key is the primary key of another table that resides in a separate table. Let me give you an example. You see this department ID? Department ID, right? Department ID is the primary key in department table, right? But when we move it to employee, it becomes what? A foreign key. What is a foreign key? Department. Now, location here is what? The primary key. When it moves here, for us to bring these two tables, it becomes what? A foreign key. So a foreign key is a primary key of another table that resides in a separate table. Does that make sense now? Is it clear? Okay. Um, Sorry, I was at the board explaining something. Okay, those of you online, what we are talking about is a foreign key. What is a foreign key? We said a foreign key is a primary key of another table another table. Now, the example we cited is look at if you can look at my screen, you will see where it says location, a table called location, right? And then it has location ID. Now, if you look at department, the last item in department is what? Is location ID. So the one in location table is a primary key. When you move it over to department, it becomes a foreign key. Somebody is asking why is my camera not on? Gang. Somebody is the people online are not understanding this foreign key concept. Okay. Okay. Those of you online, please look at my screen, okay, and look at the employee table, right? On the employee table, you will see the first item is what? Employee ID. And that employee ID is what? If you can't see the diagram very well, so let me just continue because I don't have a marker. No problem. The video tutorial I sent, I can add the one for foreign key primary key constraints. And then you have the unique key. What is the unique key? Mm-mm. What is the unique key? Hmm? This time? Okay, thank God. Huh? Ah, I never read you. Unique key. Wait, seriously, this time? No, we started 2:30. No, it's 2 hours for the class. Really? Hey. So, guys, how we go do? Okay. Now, we're talking about unique key. What is a unique key? Now, imagine you go to Facebook and you want to use the email that you registered to register again. You agree? Why? It has been used already. Now, that's a unique key. It only accepts that type of value once. It only accepts the value what? Once. Yes, it is a unique key. Because you cannot have the same phone number as Madam, what is your name again? Madam Ngozi. Unless you are the wrong number. Abi? Uh-huh. So unique key, your phone number is a unique key. But your name is not a unique key. Because apart from this Ngozi, I know Ngozi Okonjo Iweala. And I have Ngozi in my class when I was in secondary school. So your name cannot be a unique key. Even your full name cannot be a unique key. Hmm? Because if you go to Kano now and shout, Mohammed Kabir should come out. By whatever arrangement you do, you get thousands. You get thousands. So your name cannot be a unique key. But your phone number is a unique key. Your bank account number is a unique key. The BVN is unique. Your name, they're all unique keys. Cannot be. It should be a full unique value. Your email address is unique key. No, your password is not unique. You and your sister can have the same password. Yeah, even fingerprints. My younger brother used to open my phone. It's unique key. No, it's unique to you. It's not even possible. Now you make mistake. When we make mistake, we should accept it. All right. Now let's move forward. Composite key. Composite key happens when you use multiple columns to what? Identify a row. When you use multiple columns to identify a row, how is that possible? Let's assume you have a table and you want to use a composite key as your primary key. How do you go about it? You can. I was asking a question. I said a composite key is a key that is a situation whereby you combine two fields to make a single key, to make a single primary key that identifies the value. So, for instance, student ID and course code can be a composite key because a student ID, course code, and semester. Because a student cannot register the course twice in the semester. Or is it possible for a student to register course 2 times? The same course 2 times? It doesn't make sense now. So that is it. Favor that is climbing hills online said something that means all primary keys are unique keys, but not all unique keys are primary keys. The answer is yes. She has true wisdom give us like madness now. Say when they climb hill, congratulations, so you're doing well. Huh? When they climb hill, they laugh. Okay, now. All right, let's move on. Now, this is an example of primary and foreign key relationship in a student table. So now what this is doing is attaching students to what? What is it? What is the foreign key? What is the relationship we're doing? The relationship here, this connection here. This one and this one is marrying them at the beginning. What does it mean? It's linking the students to the marks for the courses. Okay? We will play on that in the future. Hey, how I wish I'm on my best sleeping. Somebody is wishing for us online. So let's all wish something. Now, the last item on the agenda, normalization. Again, the hard part of database design. Normalization. What is it? Normalization is the process of organizing data in a database efficiently. Efficient what? Now, this includes reducing what? redundancy. What is redundancy in data? Repetition. Now, in real world, how do you apply? How does that apply? Yes. So how does it apply in real world? Hmm. Redundancy in data. Let me give an example. Let's go back to this my table. I don't know why I just like this table very much. I don't know why. Now I don't pass on. Oh God, this one. Now this is normalized. Hmm? If this is not normalized, you have the password here. You have location here. So what that will translate to is you write your name and everything, and then you say Department of Computer Science, and then you say location, Ibadan, and then you write the next person, and then you write his department. Instead of just to write the numbers, the departments, the primary key numbers. So you keep writing that particular information over and over and over and over. That leads to what? Redundancy. Because you have data all over the place. Now, if you, okay, let me give you an example. Let's assume I give you a list of 50 students. 50 students from 3 departments. One, and then I scramble them. Hmm? Let me see. Okay. Sorry, guys. Those of you online, sorry. I'm going to project my screen in a bit. So let's um, let's let's see what we can do. Kangaroo data. Those of you online will not be able to see my screen. So those of you online, please just give us a short period of time. We'll just do a small demonstration. Okay. Let's say department. Let's say 50. And then let's say preview. Okay. Okay. Now, let's assume I give you this data to type. If you notice, the number of departments are not much. So now you separate the department out and then you create a primary ID for it, a unique identifier for it. So instead of writing the name of the department, you just write that number. Now, if I'm giving you that right, and then I ask you to do it the first way, whereby you write the full name and then just look over the number and then you write the number, which one will be easier for you? Assuming you're running on just 3 departments. The second option, right? So that is the benefit, one of the benefits of what? Foreign key relationship in attachment to this thing. Let's quickly finish. So that is one of the ways you eliminate redundancy. Online participants, sorry. Yeah, I would also have loved to show you the demonstration, but then it's out of my clinical. I don't want to see my account balance. Okay. They cannot see my screen right now. This one? It's not showing on my phone. Okay, let's move on then. So, one of the things you get from, where is the play button again? Okay, I can see me. Hmm? That I should do giveaway. Ah, when Salah is in 3 days, this person is just giveaway when Salah is in 3 days, I mean 2 days. Okay, now normalization has forms. Okay, normalization has what? Forms, and those forms are up to I think 4 or 5. Okay, but the core ones that we use are 3, which is what? The first normal form, second normal form, and third normal form. Now, in each of these forms, we sanitize the data and we make the data to be, I don't know the English to use. Okay, let's walk through the forms and then we'll get to that part of the listing. Okay, the main goal of database normalization is to create a database that is flexible, scalable, and free of anomalies. Okay, there are several normal forms in database normalization. Each address a specific type of data redundancy or dependency. Okay, you have the first normal form, you have the second normal form, and you have the third normal form. In the first normal form, all tables, all columns in a table must hold atomic value, meaning that each column contains one single indivisible value. There should be no repeating group or array within the column. And then the second normal form, the table must first satisfy the first normal form, and then all non-key attributes must be fully functionally dependent on the entity primary key. This means that if a table has composite keys, each non-key attribute should be dependent on the entire composite key, not just part of it. Okay? We'll come to that in a few slides. The third normal form, a table must first satisfy second normal form, and then it must eliminate transitive dependencies. This means that no non-key attribute should be dependent on another non-key attribute. It should only be dependent on the primary key. And then you can use this right here to look at your normalization. Now, all this English that we've spoken, we've broken grammar, we've chopped English, we've Greek Queen Elizabeth. Now, in real life, how does it work? Let's take this data for instance. What are the problems you can see with this data? What are the problems? Repetition of what? Repetition of names. Mm-hmm. The subjects. Repetition. And grades. Everything is repetition. Even student ID is repetition. Hey, you know, wow. So now, does this data come with a problem? It can enter the table, but it comes with problems. That is one. So now, for us to move this data from the way it is here to first normal form, we said first normal form is the most basic level of normalization in a database. The rule for archiving first normal form are as follows. Each table should have a primary key, which uniquely identifies each row in the what? In the table. Each column in the table should contain only atomic value, which is what? Single value. It should not contain more than one value. Okay? Now, if you notice in this particular this thing, subject contains more than one value, right? Subject contains more than one value. What we want is for subject to contain only one value. Now, there should be no repeating group of data. Here you have repeating group of what? Data, okay? For example, using the student table in the previous slides, in the previous slide that stores student information about students in a school, the table is not in what? It's not in first normal form. Now, for us to bring it to first normal form, we'll have something like this. Does that make sense? Does it make sense? We want atomicity of data. Each column should contain only one data. So now, if you look at the table before, let's do before and after makeup. If you look at the table before, you see subject has what? More than one value. It has math and history. And then here it has English and history. English and history. English and history. Math and science. Math and science. Math and science. Agric and social studies. Agric and social studies. So it has multiple values in one cell, in one column, in one field. Okay? The closing time is? Yes. So now, when we break it down, we have something like this. Now, each item is in a separate field. Yes? No. The group of values is what we are trying to separate. We're looking at atomicity of data. We want just one value per this thing. Okay? Now, this data is in what? It's in first normal form. It's more, but it's much more better. Okay? Now, the table is not in first normal form. Since all the data is atomic, each cell contains only one value, and there are no repeating group of data. First normal form is the starting point for normalization. And to ensure that data integrity and consistency, it's necessary to move to the next normalization form, which is what? Second normal form. Now, what is the second normal form? You said that in break. So we break data small. Okay. Second normal form builds upon the rules of first normal form by addressing issue of partial dependencies. In second normal form, a table must not have any partial dependency. Okay? A partial dependency exists when a non-primary key column depends on part of a composite primary key. The primary key appears to be a combination of student ID and subject. Now, if you look at this particular table, how do you identify each row? You need to identify each row. Each row. This row now. So how do you identify each of these rows? This is now the first one. No, like this now. I give this table. I ask you, how do you identify? How do you what do you do? Subject. Okay, like John. If I take you take this student ID, you take this subject, and then you combine them, give you what? Composite key. Which combination of multiple fields to produce what? Primary key. Okay? So now these two are what is now the primary key for this table is bad. Okay? We don't want it like that. And that is the reason why we are trying to go to what? Second normal form. Okay? Now, we need to ensure that all non-key attributes are what? Fully dependent on fully dependent on the entire primary key. In this case, name is not fully dependent on the entire primary key, as it is functionally dependent on student ID. So now what do? We take out the names and the IDs. How do you do that? We go like this. Does it make sense? Now, if you notice, student ID name, they are now compact into what? A separate table. They are now compacted and moved to a what? A separate table. Now, instead of us to write the names and number, we just write the student ID. And then we know which student, if we say student number 1, which one are we referring to? When we say student number 3, which one are we referring to? Very good. But then still, this one here, how do I identify this table? No, you can use this and this to identify the ID of the student and what? So now, what is the primary key of this table? The student ID and the subject. We still have composite key. Be like bicycle. It's one of the funny part of this thing. So now we're going to what? Third normal form. And in third normal form, let me just cut the story short for you because you see the end result, you understand the previous what we are trying to do. This is third normal form. Do you understand now? Look at it. Look at the data from the beginning. This is the data now, right? And we said we want atomicity of data. We want each subject to have its own rule. Each subject should have its own rule, right? That is when we reach to this stage, right? And then we said, now we have names all over the place, right? We want to what? Separate them out. So we break it down and then we take names out, right? And then we have the names, and then we have the idea of the name, and then we have subjects, right? But then the subject are repeating. We have math, and we have English, history. We are repeating this, we are still repeating values. So now we want to take these subjects out and take the own table for them separate. Such that these subjects too, they will have their own separate table. So you have, how many subjects do you have all in all? Let me tell you please. 6. Unique subjects. 6, right? Now, since we have 6 subjects, is it better for us to keep writing social studies? If you have 300 students, will you keep writing social studies? It's going to be difficult for you. So what do? You create a separate table for them. And then you move your table to what? To the third normal form, which we have students, student information, subjects, and what? Results. Now, if you realize, we added a column there called what? Result ID. This result ID is uniquely identifying each row in the results. So we can say result ID number 1 is for John, and then the subject number 1 is what? Social. It's like a linkage. Do you understand? Look at it this way. Cell number 1. Who is cell number 1? John, right? Which subject is he? Which cell is number 2? What's number 2? Hassan. Which subject is number 5? What is he in us? Number 3. Who is the student? Emeka Jerry. He got in science, it's called what? very good student. No matter, unless now you go to my 2,000. Hmm? Actually, mhm. No. So, so now that is where the practical part of this class will come into play. That is when you understand the practical application of it. Okay? I don't know if I'm making sense. Right now, we are doing connection with our brain, right? What if you have 300 subjects? Let's take base for instance. How many modules do you think students are taking in base? Students are taking law, engineering, computer science, architecture, and so on and so forth. So how many subjects do you think base have? Many, right? Now, if we have to keep writing all the students' name and their subjects, we'll come to a problem in the future. So the best thing we can do is to normalize. And then students have their tables separate with their names, and then we link the students to, because look, you're dealing with data and you're dealing with data and space. This one here will contain less space than when you put all of these things back together. Yes. No, it's not, data, that's why I say you said data has relationship. Data is not supposed to stand separately. Yes. It's supposed to stand with other data. Okay? All right. Questions? Those of you online, I'm very, very sorry. I don't know how to apologize to you guys really, because this class is going to be co-practical class, and it's going to be, I don't know how you're going to enjoy the class online. I'll try my best to see that you enjoy the class online, but I don't know how it's going to be. I don't know how it's going to be. So please try to see that you catch up with the class. I will try to post these notes today, and then I will post our first work that we will do in class with all of you, maybe tomorrow or next. If let us by Wednesday. Now, please make sure you install MySQL and you watch all the videos on the slide. That way, you will be conversant with things that we need to do in class. Because it's a lazy student that goes to class without knowing something about what is going to be discussed in the class. Okay? So know something that, in fact, that is why I like myself. Whenever I'm going to class, before the semester ends, I've already finished the semester in my room. So when I go to class, when the teacher is teaching, I know what he's talking about. And if the teacher is doing long cut, I'll tell him, sir, this is long cut, do shortcuts. And it's true now. So please try and see that you catch up with us. In regards to the quiz for the previous course, I'm still trying to get the total number of students that have registered for this particular course. I don't have the list yet. I'm trying to create a Google platform, a Moodle platform whereby I can post my questions for you to go and write your exams. It's going to be about 100 questions, answer all. OBG. Hmm? I tried to do dashboard, but I kept having some funny things. I want to first find time. This one is just for the exams. This one is just for the exams that I'm going to write. I can post my questions and then go and answer it. No, those ones I'll post on the listing. I'll post, this one is just for exams, the module. It's just for exams, nothing else. I'm not posting notes, I'm not posting anything, just exam questions. I don't have the time to start my thing. Let me just use the module, I'm more concerned with it. And I'm posting 100 questions. I just want to, with module, I can just arrange my questions and post single. You want me to sit down and start typing 100 questions on the Google form? This chairman, you know they pity my life. Let me be Mr. Macaroni. Are you normal? Okay. Someone is shouting 100 question. Another person is saying 300. Is it this world? It's balanced diet. All right, guys. Any question? Well, actually, I turned off my camera because my face is bushy, and I'm not looking like the handsome young man I used to look like. Okay. Okay. Any questions, guys? The whole 2 hours, no question. Yes. No, that one we'll talk about. Is it side that budge? I'll be waiting their name. We'll talk that relationship. We'll go talk for this class. No, no worry. We'll talk side that for this class. No, no relationship. We'll talk entire. No worry. One to one, one to many, many to many. We'll talk about them. No worry. Okay. All right. Any other question, guys? Okay. In the absence of questions, yes. 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 That I say is elementary. Maybe I'll give you 30 minutes for 60 questions. Yes, now. I think I've posted all of them. Oh? Which one is left? Which one is left? No. 3. Relax. I'll post it to the platform, and then everybody can go there and get them. LMS. Yes, this one I'll put the class today, inshallah.
Which LMS?
The learning management system now. There is LMS. I'm going to update it now. I told you guys I'm going to do a lot as at a few weeks ago, so that is the reason why I have not been able to. You are starting what? Yes, now. I mean, you want us to start next month? Okay, so thank God. We'll start practicals next week. Chairman now. Don't be that student that doesn't want the lecturer to go home and rest. Yes, I think so. Come again? Okay, thank you guys online. Have a lovely day. See you when I see you. If you have any question, this one have SQLite, and we're doing my SQL. Chairman, go and find my SQL and install. Okay. You can have anyone you want, but me, the one I'm going to deal with is my SQL.